I'm going to demonstrate a simple buffer overflow type situation. So I'm actually going to generate a very vulnerable program in C to do this. So first I'm going to just create a directory, and it's going to be overflow. Nothing in there right now. I'm going to do touch overflow.c, vi overflow.c, and I'm going to do include my standard input output, and I'm going to include my standard library, and I'm going to create a struct to store everything in. So I'm going to do typedef struct program data, program data. I'm going to have this program just get the user's initials, and then it's also going to store just some system command that it runs in this other buffer. So I've got these two buffers here, and the idea is that you fill up this first buffer, and then it's going to overflow into the second buffer. So just a really simple idea. So create a main function here. And I'm going to instantiate my program data. And I'm going to instantiate my initial command. So let's start with an ls command that's stored in there by default. So just putting in one character at a time just because that's one way to do it. So it's going to have that preloaded in there as a command. Null character. Terminate it. Okay. And then I'll print out the command that's stored just to show that it's there. And then let's execute that command. And let's actually have it execute the command twice. So I'll execute it once, just unchanged, and we'll execute it again at the end. So at the end, we're going to print the user's initials, and we're going to print the stored command. And then we actually haven't got anything from the user yet. So here I'm going to do a prompt to the user. Please enter your initials. And I'm going to use this function called getS. And this is actually a very insecure function because it doesn't do any kind of checking for bounds of any kind of buffer or input. It just keeps going until you get a new line character. So in theory, this should get their initials. If they just enter their initials only, then it should just run ls twice. It'll run ls once before and then once afterwards. But if you just enter more characters in the initials, it should have a buffer overflow kind of attack that you can do. So let me look here. There's my file. I'm going to do a GCC on it and see what I get. And I got some errors here. What did I have? So I think I didn't do my typedef correctly. Let me look here in the program. So typedef struct program data. Let's see. Oh, forgot the R. That's why. Misspelled it. Typo. Okay, let's try this again. And it looks like I have another typo in there, which is I have a lowercase d over here. Okay, there we go. The only thing I got left here is just this warning that the gets function is dangerous, should not be used. But we're going to use it anyway. So I'm just going to run Actually, let's do ls before I run it. So this should be the output. Actually, it should just be ls, not lsa1. So I just have these two files here. I'm actually going to create a third one. I'm going to create an important file. So when I do ls, you see there's that important file there. Now I'm going to execute my program. And then it runs that ls command, and it shows the same results as when I entered it manually. And then if I just type in my initials, first initial is G, last initial is R for Greg Ross. If I enter that, it shows my initials are GR, and the store command is still ls, and it executes it the same. But let me run it again, and now I'm going to enter my initials. But then I'm going to enter also a command. Let's just delete that important file. And you can see initials is grrm important file, and stored command is rm important file, because there's no \0 in that string, so that's why it printed all this as the initials. And the stored command, though, that just got that from the second part of from the second buffer after the first one got overflowed. So now if I run ls again, you can see that our important file has been deleted. So that's the basic idea behind a buffer overflow attack. In many cases, if you have a program and you can overflow a buffer, you might take advantage of the fact that in your memory where your input buffer is, at some point maybe like you can override, like say if it's being called in the function, you can override the return pointer if you know exactly where it's at, and then send the program to another function, and then somewhere from there you can do some kind of command injection. But that's like the basic idea behind a buffer overflow attack.